Nice. So thanks. Yeah, I'm Rachel. I work at JetBrains, and I'm going to talk about how we do software to bring IDEs to developers. And I know we have some JetBrains people in here, right, who use our IDEs. So I'm on the .NET side of it. But we're going to also talk about Java, because most of them are actually written in Java. Actually, all of them. So with a little bit of Kotlin. And then over on .NET, we throw some .NET in there, because why not? All right, so we're going to look at how we architect our product lines, also known as the platform, or the platform SDK. So we'll start off. I started at JetBrains, started working on the advocacy team and with the products. And at that time, I also decided to go back and get a master's. And the theme of my thesis was product lines, like how to architect commercial software for the ultimate reusability. And we're going to talk about reusability and how it fits into an entire platform and product, which is a little bit different than how we normally approach software as just general software developers. So we'll start with the what is these definitions. So a software product, a product line or a product family is a group of products that is built from common assets. And you might think like, oh, okay, but that's like software. Yeah, but it's not all software. And some people might go, but that's Office. No, actually it's not. Office is not built on this kind of a structure. Or it might be Adobe or this suite or a Dynamics from Microsoft comes up a lot. No, they are collections of software products with some reusable components between them, but they're entirely different products. Word is not Excel, is not Access. I don't care how many Office people tell you Access and Excel is the same. We know it's not. So that's one thing, is they kind of have to be the same. For us, an IDE is an IDE, right? Writer IDE is an IDE. It does code. IntelliJ is an IDE. It helps you write code. PyCharm is an IDE. It helps you write code. So that's the first thing we have to get down, is it's not just a collection of software for licensing or something like that. It is a whole platform of reusability, and then the different stuff that makes each product unique on top. So you do have a shared managed set of features. And these features satisfy specific market needs. And how you might grow from one product into an entire line is usually the market dictating this. And that's how it went for us. And it's how it went for a lot of companies. So yeah, we're in here, but you probably use a smartphone. Almost every smartphone out there, or even the dumb ones, they're on a product line, right? And that product line is usually in firmware. You find this all over in firmware. Cars, all the software in all the cars, and the actual physical car. Like they call it a platform, the Toyota platform, the Honda platform, right? So they actually do the same type of process in like actual hardware, car engineering and hardware. If you look at like Airbnb, HomeAway, Vrbo, they're all product lines for that kind of service, like the Uber and the Airbnb, that kind of connecting service. You find it in finance, e-commerce, and insurance a lot as well. Right? So there's a lot of areas you find this kind of software. I worked on a big insurance company in the US on a contract in which they were actually losing to the competition because they couldn't quite get the architecture right on this. So it actually does drive time to market. You could decrease that time and increase efficiency if you architect it well. So we get an idea of what a product line is, but to further define it, what is it not? It's not an API. That's just an API. Right? APIs can be part of it. It's not an API. It's not just reusability in components. As a developer, when we say the word reusability, I think almost everybody thinks, yes, this tiny thing, right? But it's not. We're going to take reusability and we're going to make it a big thing. If you're only thinking like this, you're not thinking big enough. We got to think bigger and better. So we're going to look at actual like hardcore reusability here. Clone and own, I'm going to talk about those. Those are most software out there. And then also, some software just probably shouldn't be a product line. You don't need it. That would be maybe something that would start off before it would get cloned and owned. Or software that's customizable. Simply customizing doesn't make it happen. Or just licensing boundaries, right? Buy one product, get 27 free, like whatever. No, just licensing does not make that happen either. So why would we do this also? Why architect this way? It's really good. You get to keep a code base, therefore reducing your code size when we get to what's called variability. We'll take a look at that. Defects makes defect hunting better, tracking better, calibration and maintenance across teams. You get stuff, if you know JetBrains products, you know it looks the same. You open an IDE, you know it's ours. And then Microsoft tries to steal our features. You already knew this. You didn't have to hear it from me, right? Common look and feel, right? There's a whole bunch of benefits. The downside is upfront. If you don't have a product line, you're going to have to spend some time up front. Hey, look, it's a trade-off. We got to do it, right? If that's what you want, you got to make that trade-off. So upfront costs are where it's going to hit you. But I am a long game person, right? I will take that product out. I want my software living for decades and making the young people feel the pain of using it. So that's what I want for the future. And this is a good way to get it. So upfront costs so we could torture our young people later. So you might need some specialized personnel in the beginning as well, but I could see this happening without it as well. And developers we go right for that little component, and we're gonna think bigger as we go through this talk. So let's see here. Here's what it looks like. If you start out with a single product, and then the market says, well, you're gonna take this product like your IDE, and you have this IDE for Java, and now, say Ruby folks would like an IDE and you want to build it. Well, I could take that whole system, I could fork it and start working on it. And this is what a lot of people do, right? Just fork and go. Thanks, GitHub. That works for some things, for this it doesn't. So you do that, and then you might do it again. And how many times do you think you're going to do that before it gets unmanageable? It's fast. It's really fast, actually the first time you do it. And what we found is from research in academia that there's a 3-product breaking point in which once you get to about 3 products out, your current practice of doing architecture and the break-even cross, and you actually start to get back that ROI. So it's at roughly the 3-product line. Rolls-Royce put out a paper showing how both the cars and the software that goes with them, I never think of them as high tech, more monocle dude with a top hat kind of thing. But yeah, they actually have software, and that's also what they found with their products that they've done this way. If you look at Nokia and some of the phones, you'll see similar research out there about that. So if you want to know about the pedantic academicness behind it, bottom link, it's in the slides. So what happens with the clone and own? I see this in a lot of just random corporations. I saw it at that big insurance company. They have a product, and they go and they do another. And these little trinkets in here are features. So I have this product, and I have these features. Okay, well, I want another one. So I want, maybe I have Airbnb, and I want Airbnb. Okay, so product 2, Airbnb, and then Airbnb changed. Well, now it's different. How do you manage that? Okay, well, we'll take team members and put them on 2. Okay. But we need product 3 because marketing went out and sold more stuff. Marketing. More features. Oh, changes in 1. No, more changes. Oh, marketing added yet another. Sneaky bastards. So there's another. I got more features, right? It spirals out of control. How many teams do we need? How many people? It's just resources. And then the CEO is going what? All this headcount, what the hell, right? This is also just thinking about this, right? Not the maintenance scenario I prefer, let's say, right? I'm going to say this just looks like a nightmare, and it is. This happens a lot, right? People go off and they just keep copying, or they'll take a bunch of components and start a new project for product 2. Doesn't matter, that's still considered clone and own, right? If you take a bunch of stuff and spin it off without actually architecting a base, this is what happens. And then when the bugs come, so here's a bug in product 5, it probably actually exists in the rest, but did we know that? No, not if we're not managing in the right way. So bugs fly in, they're all over the place. Like, you don't know where they're going to show up, and it's hard to manage, right? No matter how many JIRAs you have. So we say, well, maybe let's go to a product line. What can we do? We start off with a platform or a base, right? And that's where you put the reusability in. You reuse the whole software. Have we ever considered that as programmers? No, we're thinking like this. How about reusing this? You want to not duplicate your efforts, right? Reuse bigger. So we have an entire base. I have all of this that I know at this time the market dictates we have X features that are common to all of this. If it's an IDE, obviously opening files, debugging, integration with GitHub or VCS, those kind of things, it doesn't matter. What IDE, you're going to have a common branch of assets, right? Then on top of that, you just have the base, and on top of it, you add features and changes that are directed toward each project. And you can model this. The nice thing is the core you could model like it's a single piece of software. And on top of it, we do what's called variability modeling. And that's where we model the differences across those. So instead of component reusability, we're doing program reusability. Like we're reusing entire massive chunks of code. And it's much easier to manage than, and instead of a bunch of group of components here, or a group there, or an API here and a library there. So this way, I might not even have a feature. I could just kind of nix one. You know, like maybe Go doesn't have a Lambda, or I don't actually know anything about Go, but like whatever they have or don't, or Java, never getting Lambdas for a while. Ha ha ha. So stuff like that. So you can have your different features, but you have a shared core, and then you don't have this kind of stuff going on, right? Because everything is kind of linked, right? Any updates to the core gets updated across the board, and then each team could focus on the team features for the product. So, and then if you have a bug in the core, it's a bug everywhere. You squash the bug in the core, it's squashed everywhere. So your bug tracking then is core plus product specific, right? So we do that. So this is another one. Yeah, right? We do this all the time. Let's make it reusable, and everybody starts with that strategy. But other than the tiny component, are we actually reusing it? Probably not. So we have that reusability that we need to consider at a larger level. Now, with single systems and product lines, single system is easy. You just go in there, you do your thing, right? Maybe it's for HR or whatever the system is you're doing. Then we just do reuse at the component level, right, or an API. But as you see here, it's the asset. It's actually reuse as a business strategy rather than a programming strategy. Let that sink in for a second, right? It's not, you're not the programmer going, I need to reuse a component. You're the business person for this moment saying, how does reusability in this product as a product or as a feature of one of them in the family, how does that play out? How do we work with that? So that's where it really makes a difference. The business strategy will drive your reusability, right? Oh yeah, this is uncomfortable for a few programmers, right? Because business people, marketing again, right? We've met them. So if you had like an online market, these are just kind of bigger examples, but you might have like an Airbnb, Airbnb, right? And you might have a couple of feature areas, and you say, well, I want to map out so that this other, Airbnb has a point of sale, Airbnb has that, and a credit card checkout or whatever it is that they're doing. So you could kind of map out bigger features as the market decides. And yeah, you can have marketing do this. They can figure out, hey, market's going this way, we need to go that way. And you talk to your business people and you go, okay, we're going to have our platform, and in certain areas, certain market niches that we want to target, we have these overall blocks of functionality. And inside of those blocks, we'll architect those little variations per product. So we start with that big picture. And of course, you have to think, is there an actual need for this, right? Not all software needs this, right? So you think you have something, might you need to reproduce that because of the market, right? If not, then you just might, not everyone needs it, right? You design the commonalities, right? That's your platform, then the variability. So that's your big picture 3-step, right? The commonalities, like I mentioned before, here's an example like GitHub. You go in, except for the fact that this says .java on here, like it's gonna look the same in our IDEs. It's hard to tell just from this snap. Like I could tell from the shortcuts and obviously the .java, but so it's the same look. You can get the same functionality, like even though if I'm opening something in .NET, the Explorer there is gonna show a CS or maybe TypeScript or something instead. So we're gonna get that nice look and feel everywhere. I mean, you could purposefully have a different look and feel, but mostly we tend to like, companies like the same branding and the same look and the same colors, etc. So you have commonalities. So those you just kind of develop somewhat like a regular piece of software. It's the variability that gets you. So variability, so you'd use, choose your favorite. Right, so DDD, like that's all the rage now. Object-oriented design, anyone using UML out there too? Yes, I'm old school too, man, like, yeah. So there's a use in it, but some folks do use UML. We actually have a few models. Yeah, we have a few. So whatever modeling you're already using, go with it. But what we're gonna do is add in working with these specific products and targeting them. So there is, now here's where academia comes in. When I went for the master's, I had to learn all these very pedantic things that academia requires for the thesis. And you can actually go into, I'm gonna throw out some books, you could go into a rabbit hole of modeling with this. And I think they over-architect a little bit of things in academia. So I'm going to tone it back a little with some suggestions, but give you resources to go dig further. Back in the day, CMMI was a thing, and they can get into that level. Most software development does not need that level unless you're working on like an airplane, and I'm going to say anybody here even doing that? Right. So variability. So those are those features across the board. So your subject is that variable item, right? So for example, the some menu option, right? In this case, GitHub would not be variable, but a refactoring or whatever. I'm going to show one in a second. So you have the subject, your object, which is your instance, runtime instance. Variation point is where it actually changes, right? So in Writer, a refactoring to rename makes .NET code, either C#, F#, etc. In IntelliJ, it makes Java code, right? That's your variation point, is where it's going to actually change across the products. And then the variant is that representation of it at a later point. So if we were going to model this, we need to identify that thing. And this is standard modeling, right? You have to identify the thing. But the non-standard modeling is you have to identify how it's going to behave differently in each of the products, right? And then go ahead and actually do a model. So variability in our products looks something like this. If I were to do a refactoring to go from, say, a field to properties, or in Java, getter setters, I do an Alt-Enter, and here it comes up and says, hey, like, here's all your options. So that's the first variability here is I have one for IntelliJ, and it allows me, when I do Alt-Enter, to have these options, and maybe we'll just focus on the create, getter, setter one, right? Same thing here. WebStorm for TypeScript or JavaScript, right? So I could do the same thing there, the same thing in Rider, but here's the different code that's produced, right? So I have a variability point, and then that expression of what happens in code after someone interacts with it or runs that piece of code. And in a model, so you see a different code, right? And here it is, the model. So here's kind of what it would look like. So we use Notion and a few other tools, and any kind of graphic modeling tool that you have, it would look something like this. And the book's resources I'm going to give you go into detail about how to model this, should you choose to go down that point. But your variation point would be here, that getter-setter intention action, right? Specifically, I'm going to choose that option out of the menu. From it, I can generate code automatically, but the writer's visual piece actually gives you an option to do it in two different ways, right? Because C# has the classic way and then the little lambda way of doing it, right? With the automatic properties. So it actually shows you a couple extra options, and that's where the difference is in Rider. And then obviously the different code that gets produced, despite that it's the same thing happening, right? So that's what it would look like if we were to model it. Obviously, we got like 4,000 of these intentions. We don't have 4,000 of these hanging around. A great deal of these have been around in our product for a decade. So we don't need to model them every time we release something. They've already been done. So new features, we can model similarly to this. Oh, also these little lines in academia land mean things like, oh yes, they're connected across the product line. There's no weird breaks in functionality or special things you're doing. Again, I'll show you books that you can get more detail on that. I mean, I could do like a whole lecture on just the modeling. We don't need that for here. So that's kind of what it looks like. Now, how we get to this in programming, right? So from architecture down to programming. Any Java people in here? Good, great. So you will know this word, .NET people. This is a thing outside of .NET. So we actually have something in .NET with this. Old Castle Windsor, and I forget there's a third-party thing that you could do to get aspects in C#. But you could do extension points. Good old inheritance. My God, there's a use for object-oriented programming after all. Dependency injection and aspects, and a little bit of configuration. So these are some of the techniques we use to code the variabilities across the products. And what I'll do is I'll just hop over to some of our SDK and samples so you can take a look at this. So first I'll go over to, there we go. So if you go to GitHub, we actually have a bunch of code samples and IntelliJ Community Edition. You can just clone that, take a look at the code, right? You can actually, it's open source, you could contribute. But we do have these templates and samples for which you could create plugins. And ours is based on a plugin model. These variations and whatnot come out as plugins. They're all wrapped up and deployed as a plugin. So with the plugins, how we've kind of architected it is, again, we have our platform, right, the IntelliJ platform, and that's broken down into different parts depending on what it is you want to do. Like, are you going to write a plugin that actually opens files, allows people editing? Or is it a menu item? Or something that happens when you Alt-Enter? So you have these different parts and ways of working with the platform. But we do start out with the platform, and then SDK samples and templates, so you can do this. Now, if I look in IntelliJ, at these samples, the conditional operator. So for a lot of languages, you have if-then, and you have a ternary operator. .NET does, Java does, a bunch of them do. And this just lets you switch back and forth. This is our actual code that does that. This is what it looks like, right? Look at extends, or it's inheritance. So we extend from one of our components and implement some stuff, and then just go through and have the code that actually does the thing. So that's one way of us doing it, right? Extending. If we look through here, you'll find points of dependency injection. You'll find aspects for logging, but also for some of these components as well. You'll also see some Kotlin in here doing the same thing. So that should give us a little idea of some of the programming techniques that they use. So you could just use it. There's nothing, unless you're .NET, there's nothing weird. Right. Aspect-oriented programming in Java is a way to do cross-cutting concerns. Right. So PostSharp, that was the name I was thinking of. That's the one that you could use in C# to do aspect-oriented programming. So these are your techniques. So a little bit more into our platform here. So we do have what we call the base platform. It has this PSI, which is the working with opening files, all that stuff. The project model and features, and then plugins. And with our plugins, here's where it gets a little crazy, actually. Oh, that's the same slide. There we go. So if you look at like a graph of what our platform looks like, we have the black box, the platform. We actually have two, kind of, right? That one in ReSharper, because .NET, got to be different. So IntelliJ platform, all of these IDEs are built. We have more now. I can't keep this slide up to date. We're ripping them out fast, folks. So with these, they all have that common base. But if you look at ReSharper is a Visual Studio plugin. That's not exactly written in Java nor on our platform. So we had ReSharper before some of these IDEs, and we had to integrate with that. So what do? Well, the UI stuff is the ReSharper platform and some .NET stuff. But if you're doing web in like Rider or ReSharper, WebStorm is actually the thing that is doing all your web, HTML, JavaScript, and all that. WebStorm's actually a plugin. WebStorm's actually an IDE as well. It's a plugin, that's an IDE, that's a plugin. It's pluginception. That is what we're doing. Pluginception. It is. TypeScript is a plugin that's in WebStorm. It's also in Rider, because WebStorm's in Rider. Right? So I know that just went like, woo. But that's it. It's pluginception for us. So we do all of these. The platform is a whole bunch of reusable components that we call plugins. And they are managed as a group across the products, the commonality. And then the rest of them are all just plugins on top of it. Git is technically all the GitHub stuff a plugin, right? Everything is a plugin. So you can actually go into any product and so what a product then is a collection of forced plugins, right? We say, if you download this product, here's the minimum amount of plugins you get. And you can add more, right? And the ones for .NET are here. The plugins for Go are here, right? And the plugins for C-Line or C programming are here. So that's kind of what we do with our pluginception. And then we can just very easily take those templates from our own SDK and just spin up a new plugin /IDE/pluginception and write your code, and off you go. You can write code to make it Android Studio. That's what they did, right? Just off you go. There's a couple, I forget them every time, names of esoteric languages that actually were like, hey, we can quick whip up an IDE with this. And they did. I have them in the notes somewhere. I keep forgetting because I don't care. It's some language that only like 6 people use, but nonetheless, the point is that you can easily whip up a plugin this way. So here's where you could get the templates from. And those samples that I showed are part of the templates. So you can just, take that template, add your code in, and what you would need to learn would be, if you wanted to write more plugins, would be from, say, no, not from there, the website. I forgot how to Alt-Tab. Oh, there we go. Right, that's why. This one. From here, right? So you can come in here and look at the docs and see all the different things. You can even get into, custom, like I said, custom language support. We have language injection and all of that, and making your own IDE. Right? So you could do just a plugin or, go full IDE with this. So that's kind of cool that it's set up in such a way that you can do this. So. Our history, here's how this happened. Partly on purpose, partly on accident, just like everything else on Earth. Around 2008, actually before 2008, it was like Java only. If you go back far enough, it was called IntelliJ Renamer. It was like rename refactoring is how it all started. Like literally just that refactoring was like a little plug-in to stuff, and it grew to a big company. Like that's kind of our story. But we're not going back that far. We're going to go back to 2008. That's when we put together the platform as a platform. Now, it was for IntelliJ, so it's the IntelliJ platform. And that's where we did the base, the PSI for the files, calling compilers, and the project model, working with solutions and workspaces. Then later, somebody, at the top of the company said, Ruby's getting popular. Ruby people in here? Yes. I knew you were still there. I knew there was Ruby people out there. And they said, Ruby mine, we're going to do Ruby, right? Hey, I'm from .NET, so we kind of came up with Ruby, right? Ruby mine. So then they said, okay. And from the product line, created the second product based off of the market need. So here's market need for reusability, right? So we got Ruby mine. But because it was first targeted toward Java, we did Ruby mine and then a whole bunch of products. Since then, we've been sailing with products, adding more and more and more. And then around 2016, we made Rider, right? ReSharper was always kind of in parallel, kind of off its own platform. But then we were like, oh, we made this architectural decision back in the day, maybe not the best. We realized, like, we still have a lot of code that specifically targets Java in our platform, which is kind of not this whole reusability thing that I've been telling everyone about. It's not exactly how you want to do it. And it was causing little, let's say, gremlins to appear in the products and get in people's way. So if there was a bug, even if it was like a Java bug, you might see some weird stuff in the other tools, right? Okay, we're humans. We're not perfect. So then they said, what we're going to do is, we are the refactoring people. We're going to refactor massively. And we did. And right under your noses in 2023, right? And we did. So we ripped it all out and made IntelliJ an actual, this technically would have been, IJ would have been the platform. It would have been a little bit different in here. So we actually moved it so IntelliJ is properly its own product. And that actually didn't come around until later. So if you did start off trying to do product line and you did end up with a lot of core that should be variability, you can refactor it. Now, as you might imagine, you might have to dedicate some resources just for this, in which those resources cannot go pursue new business ideas, right? That is an unfortunate trade-off in cost, unless your corporation could send more money toward more resources. So there's that. But that's what we do for a living, right? If you work for, say, an auto place or insurance, maybe not. I don't know. It's hard to get money, right? It's not getting easier, it seems, either. So there's that. That's what happened. That's kind of our timeline. We ended up actually doing a major refactoring at the end of 2020 to make it a proper product line. So IntelliJ is its own product. I think there's maybe 1% that might be left over, just a few tiny things, but virtually we could say it's an actual product line. So if you're going to migrate, if you already have that system out there, if it's one, it's going to be a lot easier, or none, right? If you're starting brand new, Greenfield is the best. We never get enough of it, right? If it's not Greenfield, it's a lot harder. So you can use your traditional approach, like domain engineering and all that. Like I said before, it fits in with your modeling. You have to decide, A, if you need it, B, then sit down with your team. What's going to be the core? What's going to be on top? And on top, which targets which product? And then you have to go through the great restructuring, right? And split it off and do all your refactoring work of moving it, right? But if you have the business need, this is much better than that scenario of, breeding products. And, they are like rabbits. You breed them and then you can't control them, right? They're all over the yard, right? You just can't. So that's what you'd want to not do, right? You want to have this more cohesive structure to your software. So here are the resources. So these were written by the academic people, and they go into a great deal of modeling and stuff like domain engineering and gathering the requirements and all of that, which we don't need to know here. You already know how to gather requirements, I assume. So they tell you a little bit of how to do that in here, but this does give you some of the nice architectures and ways to approach, and some of the core points with DI and aspects and whatnot. So you're not going to find a lot of .NET in here, but it is pretty technology agnostic, so you should be fine if you're .NET. So I did it, you could do it. So that's our resources, and that's what I got. So if anybody wants to know more about the JetBrains products, I got the goods here. I got the code. You can look at the code. It's also online. You could look at it there. So I'll be up for questions. Thanks.
Thank you, Rachel. Let's head straight to the questions. Who has any? Yes, let's start here.
Thank you for that great talk. In the past, when I proposed something like doing these plugins, what I get mostly from other developers is the wish to ship the same code everywhere and do everything in configuration.
Yeah.
Like just one syntax highlighter in this example and just ship different grammatic. How do you counter that? Do you have some good examples or good arguments why this might be a bad idea?
Well, I mean, configurations gives you that problem from way back here, right? This. Right? This is what happens with not this one. That's what happens with configuration, because this is configuration, right? Say the star is, right? You can have some problems with there. Even if you kind of do put config in the core, then it's just basically a core that is at runtime kind of figuring out the platform, right? And you don't want, this is at design time. That's also developers wanting to kind of get out and code. And so there's a little bit of a people problem there, in which you're going to have to tell the developers or explain, like, it is more important to the business that we architect than just, yay, we get to write code. Because developers are much more than writing code, right? We need to build the products, or we don't have the jobs to write the code because people don't have products to buy. So that they have to get hit by the business aspect. They're backing up the business with it. But configuration creates a lot of spaghetti code if it's a lot, like in these kind of scenarios. A little bit, sure, but just for the, like anything in the core. If it's not core, like get that in components, product lines.
Thank you. More questions?
Programmer habits.
Thank you very much for the talk. Actually, I really enjoyed it, and because we also have some kind of this setup as you showed on the slides, we are building a platform, but also we are building a bunch of products in parallel using the platform, and we always face the same issue. That the products are developed in parallel with the platform, which brings into a situation that platform has to be always re-evaluated, changed, readapted, and which brings a lot of, how would I say, going back and forth. So we are kind of in a closed loop. Changes in the platform reflects in changes in the products, and then products have to refactor back the product. So how would you solve that? Because I understood that when you're speaking about line, it's like literally first develop a platform, finish, then start developing products. Or do you also have that way of continuously integrating the feedback back to the platform?
Right. Yeah, we do more of the continuous feedback. That's a great question. Yeah, I would say maybe the first product you build, you could get away with building the platform then on top. But we don't often have that luxury. So yes, you have to have an integrative cycle. So we have, like, our teams, the core team will actually bring out their product map of core features, and then the other teams around them support, look at that, and then go in parallel. And there's a lot. Sometimes some teams struggle with this too, because it is a lot of stuff to juggle, especially when we have so many products. So there can be clunkiness there we do have that. But yeah, it definitely has to be like a back and forth cycle where core makes some changes, then everybody makes some changes, and then back to core, the feedback goes back, and you have to keep the cycle going. Yeah, after that first one. Yeah.
Yep. Thank you.